All right, so I'm just going to go over basically what you're going to do in the lab. And I know sometimes it seems silly that I'm having you physically move things around, but it does help you visualize it because we want to make sure that in IB that you can explain the why behind things. So I have aluminum here. That's a cation in this case because it's combining with nitrogen, which is an anion. So I know it's an ionic bond. +3 for aluminum, -3 for nitrogen. I know it's a basic ship. I don't even have to crisscross because +3, -3 balances. But I want to show physically how that's working. So I'm going to do the electron dot structure of aluminum. Yes, and I have these very fancy electrons here. Aluminum has 3 electrons, okay? And then nitrogen is a -3, which means he's short electrons, which means he has 5 electrons. And I'm not putting these, I'm not really concerned about where you're actually placing them when we're working on the bonds because you're going to physically be sliding them around. Okay, so nitrogen has 5. Now I know for the octet rule that I want to have some sort of transfer to take place so that each of the ions can have a full crown or a full set of 8 electrons in their outer energy level. Okay, so aluminum's positive because he's +3, which means it's easier for him to give up 3 electrons. Nitrogen is -3 because it's easier for him to take 3 electrons to become 8 as opposed to giving up 5. Now that we've worked on ionization energy, you can understand why it's a lot easier for me to give up 3 than it would be to give up 5 because of those electrostatic charges. Okay? So aluminum's going to give up its 3 electrons. And when it does that, now we can see that nitrogen has 8 electrons. Aluminum still has 8 electrons though. He's now isoelectronic to neon. So he still has a full new set of electrons. He's just gotten smaller because he's been able to take off that outer ring. So this is just physically showing how that works. We have aluminum now, okay, which has a +3 charge, and is going with nitrogen, who now has a full octet rule and a -3 charge because he has 3 extra electrons on there than what he's expecting, and nitrogen is negative. So this is how you would write down that ionic Lewis dot structure. Hydrogen down here, it's 2 hydrogens, 2 nonmetals. Okay, so we know that's not an ionic bond. They're not doing a plus or minus here. They're going to be doing a share. Hydrogen has 1 electron. Hydrogen has 1 electron. And so hydrogen doesn't want to just transfer this electron over there because then this hydrogen is going to be unstable because he has no other valence electrons. He can't go to a smaller set. So he would just have that proton in the nucleus, and that's going to make him unstable. He doesn't have that electrostatic attraction going on. So he does not want to transfer. So even though this is green and white, these are both just 2 separate neutral atoms. But what they can do is they can share. And now hydrogen over here can pretend that he has 2, and he's isoelectronic to helium. Okay, he can pretend to be. Okay, and then this hydrogen over here can also pretend to be. So they're happy here in this sharing bond. And this is how you'd write the Lewis dot structure for H2. Okay, and this also shows you why this guy wants to be diatomic, because he's happy like that.